Welcome to today's lesson on graphing inequalities. So as a quick review, let's look at these four inequalities and how we would graph them. So for A here, we have x is greater than -1. So we want all of the values that are greater than -1. So here's -1. We want everything greater. Anything greater will be to the right on the number line. So 0 is greater, 1 is greater, 2 is greater, 1/2, or 1.5, 1/2, -1.5. So all of these values are greater than -1. Now instead of drawing a million dots, what we can do is just draw a straight line to shade it in. Now what we have to do is we have to decide what to do with the -1 here. So is -1 greater than -1? So since -1 is not greater than -1, it's equal to, we can't put a closed circle there because it's not true. -1 is not greater than -1. So when we're graphing inequalities, what we will do is we will have an open circle at -1. Okay, that tells whoever's looking at this graph that we're looking for all values that are greater than -1 but not equal to -1. And again, we can shade those to get all the values. Remember to shade the arrow as well. All right, so B is a little bit different. Here we have x is greater than or equal to -1. So again, we have all the values that are greater than -1. However, this time we have the equal bar here. So we can ask, is -1 greater than -1? Obviously not. But is -1 equal to -1? And that is true. So we're going to have a closed circle at -1. We're going to shade everything to the right that's greater than. All right, so whenever we have an equal bar, we're going to have a closed circle. Anytime we do not have an equal bar, we're going to have an open circle. All right, let's look at C here. C has a slight twist. Here you can see the variables on the right. And normally when we see a greater than symbol, we think we're going to shade to the right. But if you look at this, let's just take 0 for an example. Is -1 greater than 0? And that's obviously not true. So we're not going to shade to the right. We're actually going to shade to the left, which seems a little counterintuitive. So again, I would highly recommend when you see a variable on the right to go ahead and flip the expression so the variable is on the left-hand side. And when you do that, you also have to flip the inequality into the other direction. So now we have a correct statement. We want all the values for x that are less than -1. So we want all the values less than -1. And then there's no equal bar, so we're going to have an open circle. So open circle at -1, shade to the left for everything less than. And then for D, we do have that equal bar, so we're going to have a closed circle at -1. And we want everything less than -1, which is to the left. All right, so your turn. Go ahead and look at these on your own. Remember here, D, the variable's on the right, so you're going to want to go ahead and flip the inequality statement so that the variable is on the left. So give it a try. All right, and there we go. So again, anytime there's not an equal bar, we have an open circle. Anytime there is an equal bar, we have a closed circle. And then for D here, flipping the variable to the left, we also have to flip the inequality. And there you have the graphs. All right, so let's move on to inequality phrases. So this can be a little tricky. Here are some key phrases that mean the different types of inequalities. So is less than, is fewer than, has a less than, is greater than, is more than, is greater than, is less than or equal to. That one's pretty obvious, less than or equal to. These are the tricky ones. Is at most. or is no more than. It has the word most and more than in there, yet we're looking at a less than symbol. And that's true if you think about this in terms of money or age. If I have at most $10, that means I have $10 or less. If I have no more than $20, that means I have $20 or less. Right? And then we kind of have the flip side for greater than or equal to. We have at least and no less than. So here we have least and less, yet we're looking at greater than. So at least, again, if my age is at least 20 years old, that means I'm 20 years older. And if my age is no less than 40 years old, that means I'm 40 years old or older. So you can think of this no more than as not more than, and this no less than as not less than, and that might help you out. All right, so why don't you go ahead and write some numbers. So write all the numbers that are at most 6. So at most 6 would be if I had at most $6. And write all the numbers that are no less than 3. That would mean I have no less than $3. So just go ahead and write a few numbers. Obviously, you can't write them all. That would be impossible. All right, so the numbers that are at most 6, well, 6 is at most 6. If I have at most $6, I could have $6. I could have $5. I could have $4.50. I could write fractions too, like 1.5. And here I can get into the negatives, like -7. How about all the numbers that are no less than 3? Again, that's going to be greater than or equal to 3. So I have 3. I could do 10.5. I could do 47.3. So any number that is greater than or equal to 3 is no less than 3. So let's take a look at writing some inequalities based on some phrases. So a number C is less than -4. So when we did equalities, we always looked for this keyword is, and that told us where the equal sign was. Well, now we still look for the is, but then right after that is, we have the inequality. So is less than tells us what the inequality is. And is less than would be just a less than symbol. On the left, we have C. On the right, we have -4. All right, looking at B, a number K plus 5. Here's that is. So what's the inequality? Is greater than or equal to. So greater than or equal to. So we have K plus 5 is greater than or equal to 8. And last but not least, 4 times a number is at most. That's one of these tricky ones. It sounds like it's going to be greater than or equal to, but remember, if I have at most $16, that means I have less than or equal to $16. Okay, now on the left-hand side, I have 4 times the number Q, which is going to be 4Q, is at most 16. All right, go ahead and try some on your own. Really, the tricky one is this at least. So if the temperature is at least -6 degrees, think about which inequality you would use. All right, so for A, a number n is greater than, n is greater than 1. A number w minus 3 is less than or equal to, 10. And a number z divided by 2 is at least -6. So if it's at least -6 degrees out, that means it's greater than or equal to -6. And then I need the z divided by 2. All right, the last thing we're going to do in today's lesson is checking for solutions. So remember from equations, a solution is a value that makes this inequality statement true. So remember, for inequalities, there are an infinite amount of numbers that would make this true. So there's an infinite amount of numbers that are greater than 7. We're going to see if we substitute in 8 for x, do we get a true statement? So just like we did for equations, substitute in our value for the variable, and we're checking, is that greater than 7? And 8 plus 1 is 9, and 9 is greater than 7, so I put a little check. I say it is a solution. Looking at B, I'm going to substitute in 4 for y and see if I get a true statement. So I have 7 times 4. Is that less than 27? Well, 7 times 4 is 28. And 28 is definitely not less than 27. So I put a slash through it because it's not less than, and I say not a solution. And for C here, I have z over 5 is greater than or equal to 5. That means whatever I get here could be greater than or it could be 5, and this would be true. So let's see what we get here. So I substitute in 15 for z. So is that greater than or equal to 5? 15 over 5 is 3. And 3 is not greater than, and 3 is definitely not equal to 5. So put a slash and not a solution. All right, so here's some on your owns to try. Just a quick heads up for A, B, and C. All of them have the equal bar, so it would be true if it is equal. And then for C, it's a little tricky here. You don't have to do the division after you substitute in the 5. Just think, is this fraction that this turns into, is it less than or equal to 1, or is it not? All right, so A is not a solution. 4 is not greater than or equal to 7. B is a solution because 10 is greater than or equal to 10. 10 is equal to 10, so it is a solution. And then for C, you end up with 5, 6. Well, 5, 6 is definitely less than 1, so it is a solution. All right, that'll do it for today.